Hello guys!
So today, we're going to experiment on kinetic energy of rotation and torque.
And we're going to discuss the 6 topics or subtopics in this area.
Of course, we're going to make sure that we will discuss it thoroughly of each concept. So what are we waiting for? Let's go!
In today's video, we're diving into rotational dynamics, something we all encounter in our daily lives even if we don't realize it. I'll share some personal examples of how understanding these principles has made my life easier and more efficient. First is kinetic energy rotation. Rotating objects store energy depending on their mass and speed. By understanding this, I optimize their ceiling fan for better efficiency. Second is torque. Torque is the force that makes things rotate. Applying force farther from a rotation point increases torque, making tasks like opening a jar easier. Second is torque. Torque is the force that makes things rotate. Applying force farther from a rotation point increases torque, making tasks like opening a jar easier. Third is cross product in torque. Torque involves the angle of applied force. Understanding this concept helped me use a wrench more effectively. Fourth is torque and angular acceleration. More torque means faster rotation, like speeding up a merry-go-round. Applying this to a garden hose reel helped me control its speed. And lastly is internal torques cancel. In systems, internal forces often balance each other. This knowledge helped me stabilize a rotating platform in a project.
Okay. So I'm going to show you an experimental setup for rotational dynamics concept. First, kinetic energy of rotation. So in this example, I'm going to spin a can with a string measure the time and number of rotations. So the key concept of this is the faster an object rotates, the more kinetic energy it stores. This energy depends on mass and angular velocity.
So the second concept is the introduction to torque and rotational dynamics. So for example, apply force at different distances from a door's hinge and observe how torque affects the door's movement. So torque is the product of force and distance from pivot, making it easier to rotate objects at farther points.
So the next is cross product. So I'm going to take this weight and put this on the roller. I'm going to put this on a different angle to see the difference and try to calculate the torque and the torque using the cross product. So the concept here is where the cross product helps the effective force contributing the torque, especially when the forces are applied at angles.
This concept
Ayun
is...
yan.
Okay, 1, 2, 3, go. So the next concept is torque. Example, place weights at different points of the ruler and balance it. Torque increases with the distance from the pivot, making it easier to rotate objects when the force is applied farther from the axis. Muna!
Fifth, relationship between torque and angular acceleration. Use a coin and roll it in the ruler. Observe how increased force leads to faster angular acceleration. The concept is greater torque results in greater angular acceleration, demonstrating the relationship between force and rotational speed.
So the last concept is internal torques cancel in pairs. So for example, place equal weights on both sides of balance bar to observe how torques cancel each other out, maintaining equilibrium. The concept here is in balance system, internal torques cancel leading to stability and balance force causes rotation.